Hey everybody, in this tutorial I'm going to show you how to create your own milling tool for the CNC router. We will be using a spiral O flute from toolstoday.com. It's a Amana tool. This is primarily going to be used for CNC router cutting aluminum sheet metal and plastic. It has an 1/8 inch diameter, a cut height of 1/4 of an inch, shank diameter 1/8 of an inch, overall length of 1.5 inches, and it's a single flute cutting end mill. $26 a piece, pretty expensive if you're breaking them every now and then. So in Fusion 360, you need to make sure you're in the CAM workspace, and we're going to go over here on the right to our tool library. You should have some sections on the side where you have your tools that are stored within your documents that are currently open, and then also cloud tool libraries, local libraries stored on your computer. You're going to stay away from these since you use different laptops. There's also tools from vendors. So if Tools Today or Amana had their own tool library in Fusion, we could select from here, but we have to create from scratch. So there's also these sample tools, but we're just going to start completely from scratch. First thing you want to do, if you do not have this cloud library here, you need to go into your preferences and go to the CAM section and enable your cloud libraries. This will allow you to use that tool from the cloud no matter what computer you're on. So back into the tool library. As far as the tool libraries that you're going to have within your cloud library, I'd recommend making one for the Easy Router or the CNC router. Just simply right click, new tool library, and then title it, and then make sure all your tools are being saved in there. So in my Easy Router or the Patriot router, those are our two CNC routers that run in the X, Y, and Z directions. I already have these kind of set up, but I'm just going to basically be duplicating this tool for you. So make sure you have your proper tool library selected. So we're going to be creating a tool in the Easy Router cloud library. Up here in the right hand side, we're going to go New Mill Tool. This tool is going to be a 0.125 spiral O flute. Vendor is going to be Amana. Product ID actually has a code or part number of 51471. And you don't have to do this, but it's kind of nice. I'll do it. I can copy this into my Fusion. So if I need to reorder that tool, I have the link already there and available. Basically, you just need this description, the 0.125 1/8 of an inch spiral O flute. On the cutter tab, this is not a ball end mill, it is a flat end mill. It has one flute. It does spin in clockwise spindle rotation, so we'll leave that checked. It's in inches. The material is made out of carbide. It does not have through tool coolant. The diameter 0.125 1/8 of an inch. The flute length is 1/4 of an inch. The shoulder length typically doesn't matter on this. We're going to leave that at 0.375. We don't even really have a shoulder on this tool. The shaft diameter is 0.125, the same as the cutting diameter. The body length is typically going to be the amount of tool sticking out of the tool holder or collet. Most likely when we're cutting parts on the CNC router or the Easy Router and the Patriot, we're not going to have to worry about our tool holder collisions because we're cutting fairly simple flat 2D parts. So typically the only value on here that really matters is this diameter of 0.125. And then the second most important one would be the flute length because we cannot cut anything deeper than the length of our flutes. Get a nice visual over here. Shaft, nothing to worry about there because it's a pretty straightforward, simple shaft on that tool. As far as the tool holder, we really don't even need it. This is a larger tool holder for like a Haas mill. We'll be using an ER25 cullet, I believe, but typically, like I said, we're not going to be doing any crazy complex milling where we need to worry about our tool holder colliding with our part. So we're just going to actually go ahead and delete that tool holder. We don't need it. It's just not necessary. The feeds and speeds tab. Typically, we're going to run this tool at 18,000 RPM for the spindle speed. The ramp spindle speed will also be 18,000. And this changes depending on your cutting operation and your material, but it's just kind of a good ballpark RPM for this small diameter tool spinning at a pretty high RPM. Cutting feed rate, we're going to set this at 20. This is a little bit on the conservative side, but it also depends on your material, how deep you're cutting, and whether you have mist coolant and so on. So it's a good ballpark, but we can definitely cut faster, and maybe we might cut slower, but 20 would be a good starting point for a lot of operations. We're going to leave our lead in feed rate at 20 and also our lead out at 20. Ramp is going to be 6.66. That's fine. Let's make that 10. Let's make it a round even number. Typically, we're not even going to be ramping this tool, just plunges straight down. Sometimes you'll get these calculated values feed per tooth, and that's just kind of a good baseline that will allow you to determine if your cutter is doing its job, making a chip. And this is a number that usually the factory or the company would recommend. So if I go into this tool information from the manufacturer in PDF files, right here I can get a feed and speed chart that will basically say that our 1/8 inch tool right here, cutting at 18,000 RPM, approximately be 35 to 70 inches per minute, with a spindle speed surface feet per minute of 600 to 1,000, and then the chip load per tooth of 0.002 to 0.004. Vertical feed rates, plunging, we can plunge at 10. And then post processor, this will be tool number 1. Comments, we can call this 0.0125. Or probably best, since we already have that 0.125 in the tool description, comments would be, no, that's not spelled right. Aluminum and plastic. And it will actually be on mist coolant most of the time, but that doesn't really matter because our mist coolant is not connected into our control. It's a manual switch for that. I'm going to click OK. And we now have our 1/8 inch spiral O flute. We can go and edit that. We can change any of these if we need. So this is the tool that we'll be using to router the polycarbonate or Lexan window for your coin vault.